Hi everyone. In today's video, we will be going over the Unit 3 review. So number 1, which of the graphs represents the system of inequalities? And our two inequalities are negative 2x plus y is less than or equal to negative 1, and negative x plus 2y is greater than or equal to negative 2. So first off, a lot of students will go in and solve this by elimination. You can't do that for a couple reasons. One, these are inequalities, not equals. So when you're doing that, you're solving it as if it were an equals. And two, if you solve it, the answer you get is just that point of intersection, just like if these were equals. And that's not going to be useful information because we can clearly see the point of intersection here. Before we jump in and solve, let's just notice what the differences are between the graphs. The only difference between our four options is which section is shaded. So we don't necessarily need to decide if the lines are graphed correctly or if they're correctly chosen to be solid or dashed lines. The only thing we have to figure out is whether where the shading is correct. So we are going to go through and we need to figure out which line belongs to which inequality equation. And then from there, we're going to figure out the shading. So the most straightforward way to figure out this problem is to put these both in y equals mx plus b form, so then we can easily identify which line goes with which inequality, and then from there we can do some shading. So we are going to go through, and we can also make a mini graph as we go as well. So let me go ahead and do that. I'll do that down here. This is not going to be perfect by any means. This is just to have a visual. So I'm going to copy this picture down, just the lines. So these are down one. And again, I'm not going for perfection here. I'm just trying to make a replica, if you will. So there's just kind of a duplicate of the graph. So I need to figure out which of these lines is which equation, and then we'll go from there. So let's go through and solve both of these for y, and I'll just do them in order. So we have negative 2x plus y is less than or equal to negative 1. So to get the y by itself, I just need to move the 2x. Remember, our goal is y equals mx plus b form, but it won't be an equals, it'll be an inequality. So to move this over here, this is a minus 2x, so I'm just going to plus 2x on both sides. These are going to cancel. Y is less than or equal to 2x minus 1. So this I'm just going to call equation 1. So let's figure out which of these lines is this inequality. I'm going to go to just one of these graphs since we can see the grid lines. So we start at negative 1, and then we go up to right 1. So this line right here is that equation or inequality 1. So this line on my picture is the first one. And let's go ahead and handle the shading while we're here. This is less than or equal to, so we shade down. Less than or equal to, you shade down. So I'm going to go to my drawing now so I can shade on here. We go to where it crosses the y-axis, and they both cross here. And down, you just follow the y-axis down. Now just keep in mind, I'm talking about equation 1 or line 1 right here. So imagine that this line is cutting the plane into two sections, this one on the left and this one on the right. So when I go down from here, I'm going into this section. So my shading is going to be right here. Okay, now I just need to do the same for the other line. So my other equation, the bottom one, I have negative x plus 2y is greater than or equal to negative 2. Same thing, I want the y by itself. So first I need to move the x over here. So that's a minus x. We're going to plus x on both sides. We have 2y is greater than or equal to x minus 2. And then we need to get rid of the 2. So we're going to divide. And we divide everything by 2. Now, x over 2, that's a little awkward. So there's a 1 in front of this x. I'm going to write it in for my final step. We have y is greater than or equal to, this is 1 over 2x. And then minus 2 divided by 2 is just 1. So, clearly if this line here is line 1, then the other one's going to be line 2. But what's important is the shading. So this time we have greater than or equal to, so we shade up. So this time I'm going to look at line 2. And again, imagine that this is cutting the plane into 2 sections, this whole one here or this whole one underneath it. So we start where this crosses the y-axis and we shade up. So I'm going to follow this up the y-axis. So we're looking at this whole section being shaded in. And again, when you shade, go in a different direction from the first time. So you can clearly see the overlap. The overlap is right in here. Hopefully you can see the crisscross happening here. That's the goal. So the overlap shading is right here. So I want the graph that has this part shaded in. That is graph 2. So B is my answer. Number 2, which is a possible solution to the system of linear inequalities? Here's our linear system. Negative 3x plus y less than or equal to 1, x minus y greater than 1. Once again, we don't want to solve this with elimination. Don't do that, because the answer you get may not even be over here. So we're not going to do that. And even if you got that answer, it wouldn't work. I'm not going to go into that, but it wouldn't. So don't waste your time. You have 2 options. You can either do what I did in number 1. So you can get y equals mx plus b, graph it, and then see which of the 4 points is in the graph. Or another way to do it is you go in and you check and see if the points, each point, works for both inequalities. For it to be a solution, it has to be true for both inequalities. If a point fails one inequality, then it's done, it won't work. So that's the most common way to do it, so that's the way I'm going to do it here. So let's start with A, which is negative 1, negative 2. And reminder, negative 1 is x, and negative 2 is y. So let's try it in the first equation, inequality. So first we have negative 3 times negative 1 plus y is negative 2 is less than or equal to 1. So let's simplify this. Negative 3 times negative 1 is positive 3, plus negative 2 is less than or equal to 1. 3 plus negative 2 is 1. Is 1 less than or equal to 1? Yes, it's equal to 1. So this works. Now we have to test the second inequality. Does it pass this one? Second inequality is x minus y is greater than 1. So x is negative 1. Minus y is negative 2 is greater than 1. So we have negative 1, 2 negatives make it positive, so plus 2 is greater than 1. Negative 1 plus 2 is positive 1. Now 1 cannot be greater than itself, it's just not possible. So this fails, so A is not our answer. We are going to continue this process until we find the correct answer. So we have B, -1, 2. I'm going to repeat that. First inequality, we have -3, and our x here is -1, plus y is +2, is less than or equal to 1. -3 times -1 is +3, plus 2 is less than or equal to 1. 3 plus 2 is 5, and 5 is bigger than 1. It is not less than 1, let alone equal to it. This fails, so B is out. This is not our answer. I might need this space later, so I'm going to box it off like this. All right, let's try C. Option C is 1, 2. So this time we have 1, 2, 1 +2. So we have our first inequality, -3 times 1 plus y is +2 is less than or equal to 1. -3 times 1, that's -3, plus 2, less than or equal to 1. -3 plus 2 is -1. -1 is less than 1, so this passes. So let's check the second inequality. X minus y is greater than 1. X is 1. Minus y is 2 is greater than 1. 1 minus 2 is -1. Negatives are never bigger than positives, so this fails. So, C does not work. Clearly, D has to be our answer. Now, I am going to go ahead and check D because there could be a situation where a mistake was made on A, B, or C, and so you may have marked out one of the other 3 answer choices when that actually should have been your answer. So I'm going to show the work for D just to make sure it actually works. Unfortunately, I'm going to impede on number 3's space, but number 3 doesn't require any work, so that's fine. So let's check D. D is 2, -1. 2 is x, and y is -1. Let's check the first inequality. We have -3 times our x, which is 2, plus y is -1, is less than or equal to 1. -3 times 2 is -6, plus -1, less than or equal to 1. -6 plus -1 is -7. That is definitely less than or equal to 1, so that works. Lastly, let's check the second inequality. X is 2 minus y is -1 is greater than 1. We have 2 minus -1, that becomes a plus, so 2 plus 1 is 3. 3 is greater than 1, for sure. So, it passed both inequalities. D is our answer. So we were correct in that. Number 3. I actually love problems like number 3. I kind of find them fun. So here we have multiple possible answers here, and we need to figure out which ones are answers and which ones are not. Circle all possible solutions to the system of linear inequalities below. Let's make it clear what is a solution on this graph. You can see that this middle shaded portion here is the darker shading of the 3 shaded areas. This is where possible solutions are at, inside the darkest shading. So these aren't solutions, and this definitely isn't solutions. From there, we have 2 lines that border this shaded part. The solid line, these are solutions. The dashed line, these are not solutions. So it's important to make that distinction now. So what I'm going to do is I'm going to graph these as I go. If they're a solution, I'll circle it. If they're not a solution, then I will cross it out. All right, 2, 4. That's right 2, up 4. This is clearly a solution. 0, negative 2, 0, down 2. This is on the dashed line. It is not a solution. 0, 2, so over 0, up 2. This is on the solid line. This is a solution. Negative 2, negative 3. Left 2, down 3. This is still inside the shaded area, so yes. Negative 7, negative 10. Left 7, down 10. Nope. Negative 5, 0. This is just left 5. Nope. 0, 0. Yep. 1, 3. Right 1, up 3. Yep. 3, negative 4.5. Right 3, down 4.5. Nope. 6, negative 4. Right 6, down 4. Nope. So these are the 5 points that are solutions, the rest are not. Next page. Number 4, solve the system by graphing. State the solution as an ordered pair. Reminder, when you do this, it's very important you use a ruler to help you make really nice straight lines. If you don't use a ruler, it could throw off your answer. When you graph these, you must have your answer in y equals mx plus b form. On the last quiz, I had plenty of students who, like for the second equation, for example, this is not in y equals mx plus b form. I have students graphing this equation as it currently is. If you graph it from its current state, I can guarantee you your graph will be wrong. You cannot graph from this state. So our top one, y equals 1/2 x plus 4, this is ready to be graphed. So let's identify m and b. M is 1/2 and b is 4. Remember, b is where you begin on the y-axis. I had a few students graph starting on the x-axis. We don't do that. B, we begin at 4 on the y-axis. And from here, this is positive 1 over positive 2. Rise over run. Up 1, right 2. 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 Reminder, the more points you make, the better your line is going to look. I had some students who just graphed 2 or 3 points and then their line was off. So when you have more points down here, you're going to line it up better. There's my first line. Next line. So like I said, this is not in y equals mx plus b form, so I'm not ready yet. I like to write this above just as a reminder of what I want my equation to look like before I identify m and b. So the goal is to get the y by itself. All right, first things first, the x is on the wrong side, so let's move that. That's a minus 4x, so I'm going to plus, let me do this in red, color coding here, plus 4x. These are going to cancel. 3y equals, remember we want mx plus b, so put the 4x first. 4x minus 3. Next, we need to get rid of that 3 on the y. We do that by division. Divide by 3 and divide everything by 3. These 3's are going to cancel, giving us y equals, this is just 4/3. Put the x next to it. Minus, don't cancel these. 3 divided by 3 is 1. So on this equation, m is 4/3, b is negative 1. Reminder, this is on the y-axis. So we're going to begin at negative 1 on the y-axis. And then the slope is 4/3. Up 4, right 3. Up 1, 2, 3, 4, right 1, 2, 3. Repeat. Up 1, 2, 3, 4, right 1, 2, 3. I'm going to go ahead and overlap it. This is going to be our solution. That's clearly where they cross. So at this point, I have enough points. I know where they cross, so I'm not worried about graphing it perfectly because I know where the point, the answer is. Just gotta make sure I cross here. That's kind of the main thing. I'm gonna go a little bit like that. There we go. Reminder, when you're looking to graph this, make sure you figure out where it crosses or go past it before you draw the second line. If you don't draw enough points, you're just going to be hopefully graphing it well enough to tell what the answer is. This can throw off answers if you do it incorrectly. All right, let's find the coordinates of that point. Reminder, this is x, y. I have plenty of students switching these numbers. So this point is 6, 7. So make sure you are writing that correctly. 6, 7 is our answer. Just an FYI on the test, just like it says here, solve the system by graphing, you must solve by graphing. If you decide, nah, I'm going to do substitution or elimination, this would be a good substitution setup, for instance, you will not give credit because we say graphing and we provide the graph. That's kind of a big hint. You have to graph both lines to get your credit. Number 5, we have another one of these, but both of these equations are not in y equals mx plus b form, so it's going to take a little more time to get there. So, since these are stacked on top of each other and I have to solve both of them, I'm going to move the top one over here. And then I'm going to solve both of these and then graph both of them. So, per usual, I'm going to do the one on the left in purple, so that's my first one. Reminder, the goal is y equals mx plus b. First things first, I have a positive 3x over here, and that's on the wrong side, so I'm going to move it. I'm going to minus 3x on both sides. We have 6y equals negative 3x minus 36. Get rid of that 6, so I'm going to divide by 6. Divide everything by 6. 6's cancel. Y equals. Now, if you don't reduce it, it's not the end of the world, but it is going to be easier to graph if you reduce this, since the numbers will be smaller. Negative 3 over 6 is negative 1/2. By the way, it's kind of like a bonus if you're watching this video. You can easily reduce fractions in this calculator in particular. If you have a different calculator, bring it to me and I can show you how your calculator does it. So 3 over 6, you could even do negatives. This ABC button right here is for reducing. That's pretty much the only time I recommend using it. Don't use this as a typical fraction button, please, but use this to reduce. So I have negative 3 ABC, 6, and it will reduce it to negative 1/2. So if you're not good at reducing without the calculator, this is a very easy trick to use. So we have negative 1 over 2, put the x down next to it, minus 36 divided by 6 is 6. So that means m is negative 1/2 and b is negative 6, again, y-axis, not the x-axis. All right, like I said, I'm going to solve the other equation, and then I'll just graph both of them together. All right, again, the goal is y equals mx plus b. So, first things first, the x needs to be moved to the other side. Here we have a positive 5x, so I'm going to minus 5x on both sides. These cancel. Now we have negative y, don't forget the minus, equals negative 5x minus 5. Put the x term first. Now this negative in front, we do need to get rid of it. Remember, this is like a negative 1. So we're going to just divide by negative 1 and divide everything by -1. These cancel. We have y equals, this is just going to change the sign. So we have two negatives. This is now a positive 5x. And two negatives again. This is now a positive 5. So m equals 5. And when it's a whole number, just put it over 1. And b also equals 5. Again, y-axis for the starting point. All right, let's graph both of these. I'm going to graph the left one first. So b, we begin at -6 on the y-axis. And then we go, it's -0.5. And remember, put the negative on the top specifically. Down 1, treat this as a positive 2. So down 1, right 2. 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 This is a good amount of points, but I do want to get a few more, so I'm going to go backwards. So I'm going to go back to my starting place of -6, and I'm going to go backwards. So instead of down and right, I'm going to go up and left. Up 1, left 2. Up 1, left 2. That's enough. Now I'm going to connect them. Again, the more points you have, the better your line is going to look. And now I'm going to graph my other line. B, we begin at 5 on the y-axis. And then our slope is 5 over 1. This is up 5, right 1. Up 5, right 1. Problem, I'm out of graph and I clearly need to be going the other way to see where it crosses. Again, don't draw your line from here and hope it crosses in the right place. That's a risky thing to do. So we're just going to go backwards. Instead of up 5, right 1, we're going to go down 5, left 1. So down 1, 2, 3, 4, 5, left 1. Again, down 1, 2, 3, 4, 5, left 1. So this point right here is where they meet. So now if you want to stop and draw your line, you can because we know where the crossing point is. If you want to keep going, that's fine too. All right. Now for the coordinates. I'm out of space. I'm just going to write it over here on the graph. Again, this is x, y. X is first. So we want this point. So this is -2 for x. And then -5 for y. There's our answer. Next two, solve the following systems by a method of your choice. So we say that, but each of these problems are set up with a specific method in mind. So number 6, we have y equals 2x minus 5 and -3x plus 4y equals 0. In theory, you could solve this either by graphing, substitution, or elimination. But again, when it's set up like this, it's kind of begging to be solved by a specific method. So this is a clear example of substitution. I can tell because I have one equation that's completely already solved for a letter, and the other one is x and y are both on the same side. So this would be very easy to do substitution with. Again, if you're stubborn and you want to go with graphing or elimination, that's fine. You're going to have to move some things around to do that. So if you can do all three methods, it's best if you just go with the one that's going to be easiest on you. So this is clearly substitution, and I know that because I've got one equation that's solved for a letter already. So y equals this, 2x minus 5. So that means the y in the other equation I can replace with what I've just boxed. Make sure you plug this into the correct letter. I see students plugging this into the other letter all the time, and that is not good. So we're going to put this in here. We have -3x plus 4 times replace, don't write y. I see all students will still write y and then the parenthesis. No. we're going to write this instead of the y. 2x minus 5 equals 0. So I wrote the bottom equation, and then I put the y part in for the y itself. When you do this, make sure you have only x or only y in your equation. If you have x and y, you've done something wrong. All right, from here, we're going to solve. I'm going to go ahead and distribute the 4 inside of here. So we have negative 3x. 4 times 2x, that's a plus 8x. 4 times negative 5, that's a minus 20, equals 0. I have some like terms to combine. Negative 3x and 8x, that's 5x minus 20 equals 0. 2 more steps. This is a minus 20, so I need to move it over to the right side. I'm going to plus 20. 5x equals 20. And then lastly, to get rid of the 5, I just need to divide. Divide by 5 on both sides. X equals 4. I'm almost done. Once you find your first letter, you pick an equation, plug it in for that letter, and solve for what you're missing. So in this case, I have x, I need to find y. In substitution problems, it's pretty much guaranteed that the other equation you want to use is going to be the one that you didn't set up earlier, because this one already has y by itself, so that's going to make solving for it very easy. You can use the bottom equation, but it's going to be more work. So I'm going to use the second equation, or the top equation. So we have y equals 2x minus 5. I now know that x is 4. So we have 2 times 4 minus 5. 2 times 4 is 8. 8 minus 5 is 3. Lastly, to get full points, you have to write your answer as a point, just like as if we were graphing it. So remember, this is x, y. So this is 4, 3. Make sure they're in the right order. Number 7. I had some students get tripped up by this little curly bracket here. Don't focus on that too much. I have a hunch on why that's there, but don't worry about it. Genuinely, it's not a big deal. So if it bothers you, you can just mark it out. Here we have negative 4x minus 5y equals 14, and 9x plus 3y equals negative 48. This one is asking to be solved with elimination. I can tell because both equations have x and y on the same side. That's a clear indicator that elimination is going to be best here. So we need to figure out which letter we want to eliminate. Which one's going to be easier to eliminate? Let's look at the x's. My numbers are negative 4 and 9. The numbers are different, which is going to make things more difficult, but the signs are also different, which is what we want. We want a positive and a negative, so that's good. Let's look at the y's. We have negative 5 and positive 3. Again, opposite signs, which is great, but the numbers are different. So we're going to have to multiply both equations by something to change this. So we're either going to multiply the top by 9 and the bottom by 4, or the top by 3 and the bottom by 5. It depends on which one you find easier. For me, I want to work with the 3 and the 5 because they're smaller in comparison to 4 and 9. So that's going to be just smaller numbers I have to work with. So that's my decision. So I need to multiply the top by 3, the opposite number, and the bottom by 5. Now notice they're both positive. I did that on purpose. Reminder, we want a negative and a positive, which we already have. I have some students that will multiply the top by 3 and the bottom by negative 5. If you do that, that's going to mess up your whole problem, so please don't do that. That's a very easy mistake to make. So if we want to just keep in mind where we're going with this, when I do this, I'm trying to eliminate the y. This is going to give me, I want negative 15y. And then when I do it on the bottom, this is going to give me positive 15y. And I know this will work because then I've got the same number, but they're opposites, so these will cancel. So this is what I want. So again, this just kind of reminds me of where I'm going. All right, I'm going to distribute on the top. Remember to fully distribute. 3 times negative 4x is negative 12x. 3 times negative 5y is negative 15y. Equals 14 times 3. I believe that's 42. Let me check real quick. Yes. Positive 42. And now I distribute on the bottom. 5 times 9x, that's 45x. 5 times 3y, that's positive 15y. Equals 5 times negative 48. Let me see. It's going to be 240. Negative 240. All right. Now, reminder, you add the equations. I have some students that like to subtract. First off, I know the y's are going to cancel because I have a negative 15 and a positive 15. So let's go ahead and take care of that. Now we have negative 12 and positive 45, which that's going to be 33x equals, and then 42 minus 240. That's going to be negative 198. Now this looks ugly, but it actually is a very nice number. If I divide both of these by 33 to solve for x, negative 198 divided by 33. This is just negative 6. All right, I'm almost done. Once you find your first letter, go back up here and pick an equation to solve for the other letter, which in this case is y. Now a reminder, you can pick either equation. There are pros and cons to both of these. I am going to go with the bottom equation because it's mostly positive. I've only got one negative in here. So usually when you have more positives, there's less likely a mistake to be made. So now I'm going to solve for y. So my equation is 9x plus 3y equals negative 48. 9, and then I know x, it's negative 6. So 9 times negative 6 plus 3y equals negative 48. 9 times negative 6, that's negative 54, plus 3y equals negative 48. From here, I need to solve for y. So I've got my whole number over here. I'm going to move that first. This is a minus 54, so I'm going to plus 54 on both sides. These cancel. 3y equals, I feel like that's 6, but just in case, I'm going to check. Yes, this is positive 6. And then lastly, just got to divide by 3 to get the y by itself. Y equals 2. And then write your answer as a point, just like I did in number 6. We have xy, so we have negative 6, comma 2. All right, we got 3 more of those. Number 8. 10x plus 4y equals 13. Negative 4x minus 7y equals 11. Again, this is really leaning towards elimination because the x's and the y's are both on the left side together. So let's do some elimination. So let's take a look at our letters here. We've got 10x and negative 4x. The signs are opposite already, which is great, but the numbers are different. So let's take a look at the y's. We have positive 4y and negative 7y. Once again, different signs, which is great, but also different numbers, which isn't great. So we can either work with the x's or the y's. And there's not really, there is a slightly better pick, but again, you can't go wrong with going with either of these. For me, I'm going to go with 4 and 7 because that's slightly smaller than 4 and 10. So I'm going to have smaller numbers. So I'm going to multiply both equations. Multiply the top equation by just 7. Don't do the negative because these are already opposite. We don't want to change that. Multiply the bottom equation by the 4. And just to keep in mind where I'm going, on the top, this is going to give me 28y. And on the bottom, this is going to give me negative 28y, and these will cancel. So that's how I know this is going to work. Let's distribute. And I'm going to intentionally shift over to the left here because I'm going to need this space in a moment. 7 times 10x, that's 70x. 7 times 4y, that's 28y, equals 7 times 13. I'm going to check that real quick. 91. And then distribute on the bottom. 4 times negative 4x, that's negative 16x. 4 times negative 7y, that's negative 28y. 4 times 11, that is 44. And then reminder, we add these numbers. So first off, the y's are going to cancel. I set it up to do that. I've got a positive 28 and a negative 28. 70 minus 16, that is 54x. And then 91 and 44, remember we're adding, that is 135. Let me just make sure this is going to work. Yes. And then I solve for x. Just got to divide by 54 on both sides. These cancel. X equals 135 divided by 54 is actually really nice. It is 2.5. Nice decimal, I should say. All right, now that I have my x, I just need to find my y. Again, 2 equations to choose from. The top one is calling my name. All of the numbers are positive, which is what I like. So I'm going to go with that. So we have 10x plus 4y equals 13. We have 10x is 2.5. 10 times 2.5 plus 4y equals 13. 10 times 2.5 is 25 plus 4y equals 13. And then I solve for y. So first off, I need to move the 25 over here. So I'm going to minus 25 on both sides. We have 4y equals, I believe that's 12. Negative 12? Yes. Negative 12. And then lastly, we divide by 4 on both sides. Y equals negative 3. And then I just got to write my answer. Again, this is x, y. So we have 2.5, negative 3 as our answer. 2 more. Number 9, we have 4x plus 6y equals negative 18, and we have negative 2x minus 3y equals 9. Now, you can do this a couple different ways. First off, we can do the old-fashioned way where we multiply by each other's numbers. Let's take a look here. For the x's, we have positive 4 and negative 2. The signs are different, which is great, but the numbers are also different. Not great. So let's look at the y's. We have negative 3 and positive 6. Different signs, which is awesome, but the numbers are different as well. Not great. Now here's the thing. We can multiply, if we're working with the x's, we can multiply the top equation by 2 and the bottom one by 4. But there is a shortcut here. We can turn 2 into a 4, right? Very easily. So we can make these numbers the same without having to change both equations. So if you can do that, you are welcome to. That's what I'm going to do because it's less work. If you want to multiply the top equation by 2 and the bottom one by 4, go for it. Your answer will come out the same as mine. The result will come out the same, I should say. So, but I encourage you, you can change 2 into 4. Let's do that. So let's just multiply the bottom one by 2. And we don't have to change the top one at all because the signs are already different. So this is going to give me negative 4x. That's my goal. That's going to cancel out with the 4x above it. And let's distribute. So I'm going to copy down the top equation first. 4x plus 6y equals negative 18. And then I'll copy down this equation underneath it. 2 times negative 2x is negative 4x. 2 times negative 3y is negative 6y. 2 times 9 is positive 18. And then we add the equations. Okay, so the x's cancel. I set that up that way, positive 4, negative 4. Next we have positive 6y and negative 6y. These will also cancel. So on the left side, there's nothing left, that's 0. Right side, we have negative 18 and positive 18. These also cancel. This also equals 0. Here we have 0 equals 0, which is a true statement. And true statements are IMS, which is infinitely many solutions. You can just write IMS, of course. Last one of these, number 10. 6x minus 14y equals 5. 3x minus 7y equals 5. Let's take a look here. We've got 3 and 6. Different numbers and the same sign. Remember, we have to have one of these be a negative, so that's not ideal. Let's look at the y's. Negative 14 and negative sign. Once again, the signs are the same. That's not what we want, and the numbers are different, which also isn't what we want. So I'm going to work with the 3 and the 6. They're smaller than 7 and 14. Once again, we could multiply the top by 3 and the bottom by 6, but we can turn 3 into 6. So again, we can get these numbers to be the same with less work. So I'm going to do that. So to turn 3 into 6, I need 2. Also, I need this to be a negative so that it cancels with the 6 above it. So this is a negative 2. And just so I'm keeping track, I want this will be negative 6x. And negative 6x will cancel with positive 6x. So I'm going to distribute through on that. And before I do so, I'm going to copy down the top equation again. 6x minus 14y equals 5. Distributing, I have negative 6x. Negative 2 times negative 7y, that's positive 14y, equals negative 2 times 5, that's negative 10. Reminder, we are adding here. 6x and negative 6x, those cancel, which is what I set them up to do. Negative 14y and positive 14y, these also cancel, giving me 0 on the left side. 5 minus 10, that's negative 5. That's a false statement. 0 does not equal negative 5. False is no solution. And there you have it. Now we have 2 word problems. Number 11. Tickets for the theater are $5 for balcony seats and $10 for seats next to the orchestra. If 600 tickets were sold and the total receipts were $4,750, how many tickets of each type were sold? I'm going to read that again. Tickets for the theater are $5 for balcony seats and $10 for seats next to the orchestra. If 600 tickets were sold, so that's a total, I'm going to double underline it, and the total, so we have a total coming up, receipts were $4,750. Here's the question. How many tickets of each type were sold? First, we have to define the variables. That means you pick 2 letters to put in your equations and you say what they represent. These are each worth a point on the test. So as long as you write this out correctly, these are 2 easy points to get. This problem is about balcony seats and orchestra seats, so I'm going to go with B and O. And remember, when you use a letter like O that can look like something like a 0, you can either choose a different letter entirely or just make it fancy, so I give this a little curl on the top. Now remember, we can't put B equals balcony and O equals orchestra. We have to say what about it. So these are tickets for one, and we're either looking for how much they cost or the number of them, how many. So always go back to the question. Usually the question is pretty clear on what you're looking for. This is how many tickets of each type. We know how much they cost. The B is $5 and the O is 10. So that's out of the question. We don't know how many. So B is number of balcony tickets. You have to have that number of to get the credit. And then O is number of orchestra tickets. So right there, that's 2 points on the test. Write the system of equations for the given situation. And the reason why it's underlined like that is because they just want you to come up with the equations. You don't actually have to solve them. So write the system of equations. If you're not sure where to start, a very easy starting place is to start with your totals. We know we have two equations and they're both going to equal a number. So we have a total of 600 tickets for $4,750. I'm going to put the $4,750 first just because based on the notes, that's how we always write the equations. And I wanted this to look like the notes. So we have $4,750 and 600 as our totals. So $4,750, this is money. This is our money equation. You don't have to write this down to get credit, but I know it helps some students. And then 600, this is number of tickets, which I would typically call the number of items equation. From here, both equations have your variables being added together. B plus O and B plus O. Now our only other missing detail is the price per ticket. Which equation do you think cares about how much the tickets cost? The money equation, of course. So $5 for balcony seats, we're going to attach 5 to the B. $10 for orchestra seats, we're going to attach 10 to the O. Remember, the number of items, the number of tickets equations, doesn't care how much these cost. We just want to know the number of B tickets plus the number of O tickets is equal to 600 tickets. So we don't need to attach any extra information. It's just B plus O equals the total. That's it. This equation is actually much easier to write than the one above it, but most students will get the above equation and not the one under it. So don't overcomplicate this process. And that's it. That's the problem. That's all you need to do. Number 12. Gunjot bought the meat for Saturday's cookout. A package of hot dogs cost $1.60 and a package of hamburgers cost $5. He bought a total of 8 packages of meat and spent $23. How many packages of hamburger meat did he buy? Let's go through this again. Gunjot bought the meat for Saturday's cookout. A package of hot dogs cost $1.60 and a package of hamburgers cost $5. He bought a total of 8 packages of meat and spent $23. That's a total. Question, how many packages of hamburger meat did he buy? So once again, define the variables. Let's just pick 2 letters. This one's, you gotta get a little more creative because hot dogs and hamburgers both start with H. So you can go a few different ways with this. For me, hot dogs, we sometimes just call them dogs for short. So I'm just gonna use D for hot dogs. And then hamburgers, same thing. You can either use B as in burger or you can use H as in hamburger since we didn't use H for hot dog. So on my answer key, I used H for hamburger, so that's what I'm going to do here. If you want to use completely different letters, if you want to use X and Y, go for it. Just make sure that the labels match what I'm about to write here. Remember, we can't put D for hot dog. We have to be more specific. What about it? We know how much it costs. It's $1.60. The question clearly states how many packages. We don't know how many packs of hot dogs were bought. So this is number of, and you don't have to get specific. You don't have to say packages of hot dogs. Or actually, let me rephrase that. I didn't write packages of hot dogs. I wrote hot dog packages just to make it a tad shorter. And then same thing for hamburger. Number of hamburger packages. Again, if you choose different letters, that's fine. Just make sure these labels here match what I wrote. All right, let's come up with the equations. Again, if you're not sure, start with the totals. It's going to equal the total. So again, I like to work with money first. Money is the most obvious for most students. So I'm going to start with the 23. And then the other total was 8. 23, again, this is our money equation. I'm just going to write money. And 8, this is the number of packages of meat. You could put number of items if you prefer. Number of packages of meat. So these are our two equations. Next, let's add in our variables. Leave some space. D plus H and D plus H. The only other missing information is the cost of each, which we know. We know hot dogs is $1.60, so I'm going to put $1.60 in front of D. You can include the 0 or you can drop it. It doesn't matter. I'm going to include it since I'm not solving this. And then hamburgers, H is 5. There we go. And then remember, the number of packages, the number of items equation, you don't need extra numbers because it's just the number of hot dog packages plus the number of hamburger packages is equal to 8. That's what these represent, the number of each. We don't care how much they cost in this equation, so leave it be. That's it. All right, back page. 13 is going to be quick, and then 14 is going to take a while, just warning you now. Number 13, short response, explain the solution of each given graph. So you're going to write, first off, what the solution is to the graph, and then second off, explain how you know it's that solution. So for A, we have a single line here. So remember, we're supposed to have 2 lines. So when we actually just have 1 line, that means the equations are the same. So A is the example of IMS, infinitely many solutions. And then I'm just going to put a short little explanation. Yeah. They, and they as in the equations, are the same line. I'll add that note for anyone who wants to clarify. The equations. So when you graph both equations, they actually are just the exact same line when you do it. So that's why there's only 1 line. B, this is just, we just call it one solution. So you can put one solution. You can also state what that solution is. This is not a nice point, so it's kind of hard to tell. So you just, if you want to just give it your best guess, you can. I'm going to call that 1.5, 1.8. So I'm going to put in parentheses 1.5, 1.8. Again, this part's optional. One solution is what we call this kind of graph. And we know it has one solution because it's where the lines cross. The lines cross at a point. And just to show you, be consistent, see if I can put this in here without showing the bottom one. This is my answer key that's posted on Canvas. Notice I did not put the point in there. So again, it's optional. You can just put one solution if you want. Lastly, C, the lines don't cross at all. They're parallel. This is no solution. You can put one of 2 things. You could put the lines are parallel, or you can say the lines never cross. Choice is yours. I put never cross on my key, so that's what I'm going to write. That's all we're asking for. Tell us what the solution is. Your options are IMS, one solution, or no solution. And then just give a quick explanation as to why that's the solution or how you know that's the solution. All right, number 14. If xy is a solution to the system of equations below, we have 3 questions to answer. So let's back up here. This right here is a system of equations. We've got 2 equations. They're just not stacked on top of each other like we're used to seeing them. So that might make it a tad more difficult. So there's that. But they're saying if xy is a solution, we need to find what x and y are. So if we have the system, we can solve for x and y. So let's do that. You can't really go wrong with any of the 3 methods. You could very easily graph these. You just don't have a graph under here. So if you want to hand sketch it, you can. Just do this carefully because obviously if it's a little sloppy, it's going to be really hard to find the answer. You could also easily do substitution with this. That's actually the way I'm going to do it in a minute. Or you can do elimination. If you stack them, the only thing is the x's need to be in the same place, so you would need to move, probably flip the 8 and the negative 2. X would be my suggestion. So, but we haven't done any elimination problems like this, so maybe avoid that on this one. Like I said, I'm going to do substitution. So both of these equations are solved for y. Don't overthink it. So let's just take the first one. Y equals that. I'm going to put it in place of this y right here. Okay? So I'm going to write this equation, but instead of y, I'm going to write that. So we have 8 minus 2x instead of y equals 3x minus 7. So again, y equals 8 minus 2x. I took that and I put it in the other y's place. It's just not usually by itself already. So that's why it looks a little weird, but the concept is still the same. So now instead of y, I have that expression, and then the right side did not change. And now I just have x's in my equation, and I can solve. All right. First things first, when you have 2 x's and they're on different sides, you want to move one of them, preferably the smaller one. So I'm going to move the minus 2x. This is a minus 2x, so I'm going to plus 2x on both sides to get rid of it, or to move it. We have 8 equals 3 plus 2 is 5x minus 7. 2 steps to solve. First, I got to move the constant. So this is a minus 7. I'm going to plus 7 on both sides. 7's cancel. 8 plus 7 is 15. Equals 5x. Lastly, I just need to get rid of the 5 on the x. We're going to divide by 5 on both sides. 5's cancel. We have x equals 15 divided by 5 is just 3. So x is 3. All right, we need to find y. So, yeah, I have space. I can do it over here. Both of these equations are great equations because on both of them, y is already by itself. So you can't go wrong with whichever one you want to use to figure out the value of y. I'm just going to go with the top one since I haven't technically used it yet. Or sorry, the one on the left. Since I haven't used it yet, I'm going to plug this x into here. So we have y equals 8 minus 2x. We know x is 3, so y equals 8 minus 2 times 3. Y equals 8 minus 2 times 3 is 6. Y equals 8 minus 6 is 2. So these are my 2 answers. You don't have to write this as a point because this isn't our final answer. These 3 questions that we answered, that's our answer. So, just for why not, I'll go ahead and write it as an answer. So we have x, y. X is 3, y is 2. Now, we still need to figure out what these are. So we have 3 questions here. So number 1, what is the value of 2x minus y? We know x and y, just plug them in and get a number. 2 times, sorry, I'm trying to figure out what color I want to use. X is 3 minus y is 2. If you're not sure, you can type this into a calculator. Just follow your order of operations. First, you multiply. 2 times 3 is 6. And 6 minus 2 equals 4. So 4 is our first answer. It's number 1. Number 2, 3x minus 2y. Three times x is 3 minus 2 times y is 2. Just a coincidence. 3 times 3 is 9 minus 2 times 2 is 4. 9 minus 4 is 5. One more. Question number 3. Y plus x. Now they switch the letters, the order of the letters to try and trick you, so just make sure you're paying attention. Y is 2 plus x is 3. 2 plus 3 is 5. So 4, 5, 5. Those are the numbers. So this question, this is like a multiple step kind of question where you have to answer the system of equations and then take those numbers and do something else with it. So just finding the answer 3, 2 isn't enough. So make sure you're answering the question that's being asked here. All right, that is all for this video. I hope that this video was helpful. I hope it answered any questions that you may have had beforehand. If you still have any additional questions, feel free to watch and rewatch parts of the video over and over. Listen to the explanation. Hopefully it helps. If you still have questions after that, feel free to reach out to me via email or come talk to me in person before you test. Otherwise, I hope you have an awesome night. Bye!